So like you're the main presenter. You presented this at API Days in Paris about a month or two ago, right? So this was a JSON Schema conference. And there's been a lot of new things happening that you will show us today. And so yes, Loic is a product manager in the Oracle database group. So is Herman Baer. So Herman leads a lot of the JSON issues, including JSON duality views, for example. I am from the product development part. I see a chat here. Someone says my audio is not very good. Is that true? Like, Loic, can you hear me?
Yes, I can.
Loud and clear. So probably
hear
it's
you fine as
loud
well.
and yeah.
But
So
you can
the
talk to the mic.
yeah. So if you have any questions, so I see a good number of attendees. Loic will be the main presenter. And if you have any questions, Herman and I will monitor it, maybe interrupt Loic if the question is relevant, or we do a Q&A at the end, but let's make this interactive. And with this, I hand it over to Loic.
Yeah, thank you, Beda. Thank you everyone for joining for today's meeting about the JSON schema. And well, I will try actually to show you how the database and the JSON schema both get in more and more synergies for improving your productivity, managing API contracts. So basically helping you. So just let me, yeah. So here is the agenda. I will start first with the new features that we bring with the latest version of the Oracle database 26 AI. So regarding JSON schema and API development, that's where I will try to make the parallel between JSON schema and the database, showing you how we can create them, store them, generate them, a lot of operations around JSON schema management, and then drill down into, well, the database feature that actually would benefit from using the JSON schema all together, like JSON relational views, but not only these. And we'll conclude with a very short roadmap, but just actually showing you that we are continuing our efforts into supporting JSON schema. So let's start with some of the new features that we have introduced lately. So you know that the 26 AI, the version on premises on Linux platform, has been released last month. Well, we have a bunch of versions which are actually free, like container images, which are multi-platform today. We have this freesql.com website where historically it was called LiveSQL, now it's FreeSQL, and we guess what we can have SQLite access to it. We usually have live labs, of course, and as well the free autonomous AI database cloud service available for you. The 26 AI has been, this version has been developed for a number of years, beta tested for a number of years as well. And if you come from the 19C world, actually, you will see that, well, we bring and the new features from the 21Cs, close to 300, and the new features, of course, from historically 23C AI and not with 26 AI. So it's close to 600 plus new features to discover. Some of them definitely helps for the JSON data management, like native data type, JSON schema support, of course, or JSON relational duality views, but there are a lot of other things to check, like SQL functions and operators like JSON patch, JSON diff. I will have some words about it today, but as well the latest GraphQL operator or the new time bucket for time series analysis. So a lot of things to discover. I cannot speak of everything today, but definitely worth checking the new features guide. And I wanted as well to talk about the ecosystem that grows around the Oracle database, and not just the Oracle database software, but as well middlewares that we can refer to sometimes like Oracle REST Data Service or SQL the command line that well, grow more and more now with MCP server inside. We have these famous extension for VS Code, so SQL Developer for VS Code. Apex as well grows and more. And well, it's not finished actually. And as well, we provide other MCP server like a full documentation index so that, well, your LLM can actually know the up-to-date knowledge from the Oracle documentation itself. So all of this is usually free software available for you developers. And so that's what actually I'm using every day, including not just JSON schema development, but today is the topic. So let's start with the basic, and what I'd like to have is this mental image in your mind. So basically, a database, if you look at it from a very high level, it's two things. First, you have this database dictionary. This contains the database metadata, and here you can see some internal tables, like there's a tab dollar, which contains a list of tables into the database, the columns, the constraint definitions, it's the domains associated to columns, and at the bottom you have as well database data, which essentially are just rows inside tables. So here, employees and departments. Now, if we made parallel with JSON schema, well, basically that's it. Right, JSON schema here to not only validate your JSON document, but as well to provide the structure required to your data, like, well, the dictionary of a database. And for the JSON document, well, that's data, basically. And so, last but not least, this is all about data integrity. Whatever the words you use, we want the data to be completely, to be confident with the data. And last but not least as well, I remember that a JSON schema is a JSON document. And that's very helpful when you consider all of the features that we have inside the database for managing JSON. So let's get started with how actually you create or generate a JSON schema. Well, basically, JSON schema can be, at the first sight, can be a bit hard to work with. So that's why the first thing that we can do and that we have provided is this ability to kind of translate the metadata that we have inside the database dictionary into a corresponding JSON schema with handling columns, handling types, constraints, enums, and so on. So we have this package, DBMS JSON schema, and the describe function where you can specify a table, a view, a domain, or JSON Duality view, and it will just generate for you the corresponding JSON schema. The second one is as well an ability that we provide since a long time, where you want to basically create a JSON schema, not from the database metadata, but rather from the JSON data itself. So imagine you have a collection, you have numerous representative data, and you can generate basically your JSON schema that way using the JSON data guide function. So that's another way to derive JSON schema from JSON data. But the thing is, you need to have JSON data, or at least enough. The second way actually to work with JSON schema within the database is actually to store these JSON documents within either the dictionary. So the point number 3 is you can actually create a database, a data use case domain within the database, and you can enable the validation that way. So you extend kind of the scalar JSON data type, and then you provide the text for your JSON schema. I'm providing as well an example where we introduce a cast keyword, where actually you can control using what we provided as a database vocabulary, so some kind of extension to the JSON schema standard, some keywords to actually control the binary encoding, the binary serialization of your document, so that you can specify, for example, for a timestamp, well, the real SQL timestamp data type, not just a string. And of course, the last way is definitely, well, you can create a table, create a JSON column, and just store your JSON schema within the JSON column. So with that approach, it's very free for you. You can definitely leverage all of the features that we provide, like indexing for fast access and a bunch of other features. Now, on the validation side, once we have the JSON schema available, we can use continue to use the DBMS JSON schema package to validate a JSON schema, to validate as well data from, say, a table here. So we validate the data here according to a given JSON schema. So very short here, just for the example. And it's just basically telling you yes or no. But if you want more details, like generating a report with all of the different errors it found out for a given document, then you can just use validate report function. And as well as something very interesting, you can rely on the is or is not JSON operator with the new validate keyword, where you can just pass afterwards a JSON schema, and then it will just, for example, find out within the table the documents that respect or don't comply with a JSON schema. So now let's drill down into very much more interesting use case as I finding, because basics is really to validate, but next is how you can leverage them for a day-to-day activity or very specific needs. Like that one, I really like it because that's, well, the other side. So we said just before that we can generate from the dictionary JSON schema, but guess what? We can actually generate a relational model as well from a JSON schema itself. So that's where it starts beginning interesting. So let's take, for example, a table with a data column, and then you specify for that column JSON schema. So you just name it like the title, you provide different properties with constraints, and then you just need to use this new DBMS JSON duality in first schema. You pass some arguments, like we want to normalize, we want to use flexfill, and I will just explain what it means. And we provide updatability for, well, guess what, the JSON Duality view that it will be generated as well. And then you get a new relational model with foreign keys and here a child-parent relationship, because, well, you have an array here. And then it provides as well the code for generating your JSON relational duality view. And the interesting thing about it is that you keep the schema flexibility thanks to the flex field here. So whenever you have a new field that is not defined within, let's say, the columns of your tables, well, you can just store them within an additional JSON column for you. So you still continue to add this flexibility. So a bit more about JSON relationality views, just maybe as a reminder for some, but for brand new people, that's interesting to know. It can be so generated with JSON schema, SQL, or GraphQL commands. And basically, it can help you expose parts of a relational model as a JSON collection. When I say parts, it means that you can create as much JSON duality views for a given relational model. So depending upon which entry point you want for your JSON document hierarchies, or if you just want to expose in a read or read-write way some parts of your model. So you can basically do any kind of CRUD operations in JSON, like very simple API, SODA API, for example, or basically in SQL as well. So you can manage your data in both ways. And then once you get a relational model, well, for your JSON data, it means that any relational model feature can be used, like foreign key, avoiding data duplication. You can index it, of course. You can partition your table, run with analytic functions, protect your data with row-level security, and more and more. Schema flexibility, I talk about that, but basically, if you consider the additional properties to true, that's what it brings to you, right? So still flexibility regarding unknown JSON fields. Last but not least, we provide as well optimistic concurrency control. So if you think about the HTTPS world like e-tags, that's basically what we are adding. So free optimistic concurrency control within the JSON relationality views. And of course, they get natively compatible with the MongoDB API. So the MongoDB API is, well, in few words, a way to let you your application or MongoDB tools or drivers access the data stored within an Oracle database, JSON data, of course. But here as well, relational models through JSON relational duality views. So a lot of things to discover, but that's not necessarily the topic of today. So now let's get into some nice thing that we have introduced into supporting JSON schemas. So for example, in 26 AI, we have introduced the enums. Enums are basically a way to store data or store pre-known values within a data use case domain. So you create your domain, you say it's an enum, and then you specify the values here. Then you can use that domain as kind of new data type that way. And when you want to insert your data, you just leverage the domain with the currency here, euro. That's the one here. And when then you describe, meaning you generate your JSON schema, well, that's how it gets. You get the DB domain. You have a reminder about the domain that we were using before. So that's basically the database dictionary. Sorry, not dictionary, vocabulary. And then you get the possible enum that your field must respect. So very nice one. As well, something very that, well, you can speak about it a lot when you are working with JSON schema. It's about versioning. Versioning JSON schema is a topic in itself because you don't want, well, to mess with your data, given that you have a new version of your API, and so you expect a new version of the data coming in or out of your API. So from the latest standard, now we want to introduce new fields starting with X dash. So that's a requirement now, and more with the incoming V1 of the JSON schema standard. But here, I wanted to present a way to actually manually manage versioning of your own schema, basically using the flexible data use case domain feature. So here, imagine you have a JSON document here. You specify the version, so it means it should comply with version 1.0.0. A flexible data use case domain can let you actually, based on the value of this field, choose which JSON schema you want to apply for validation. And I will show you actually programmatically what it means. So you start with, for example, defining 3 domains, having each 3 attached JSON schema, one of which would be tagged version 1.0.0. The 1.0.1 has a new field, B of type number. And then I create an impossible, actually, JSON schema that can not answer anything. So the thing is that's for falling back and throwing error in case you enter anything else. And basically, well, there is no property, but it expects none as well. So you can insert nothing. And then you define your flexible domain. So you say that's domains, the domain is based on data column, and then you choose from another version column which value will target to which JSON, to which data use case domain with the attached JSON schema. So it seems a bit hard to understand, but well, basically you define your table that way. You have your data that you will want to store within that table, and that's a JSON column. Within it, you will have the X-version column being added to all of your document. And then you have this version column, which is actually a virtual column. And this virtual column will be used by the data, the flexible data use case domain to redirect to the right JSON schema to be used for validation. And because that's a virtual column, its value is basically extracted from the JSON document inserted within it. So in the case it's 1.0.0 that is fit into that field, then the validation JSON schema will be the one at the top here. And I think now you get the idea. So very efficient, very simple approach as well, still manually. So we don't manage necessarily an automatic way to version your JSON schema yet, but that's actually what you can use today. Other things around security and bringing more and more synergies, as you will see. So we have a way actually within the database to hide a column. So basically you make it invisible that way. And when you insert your data, the column is there, but you have to know it and explicitly use it, for example, within your insert statements or within your SQL statements. So for example, your select statements. So if you describe the trader value, you will see that there is no salary, just a name, right? Salary is not there. If you do a select star, same thing, the salary column is not there. And guess what? When you describe the table, well, we don't generate the part of the JSON schema for that column as well. So that's basically a convenient way to hide and benefit from that within your JSON schema as well. Now, if we get a bit more into the JSON schema management, now that we can modify JSON, and so JSON schema using SQL. So for that, we have different approach. One of them is definitely leveraging this very powerful JSON transform function. And with that, you can actually use a lot of operators like replace, set, or prepend when you have arrays. And well, here is an example. So you take a JSON document, here a JSON schema, and I want to replace the schema version here with v1. So that's what I'm doing. So the schema field, $schema field now is the one with v1. I want to set a new property, the h1, within the properties object and say that's this JSON document, this JSON object. And I want to add to the required field property the field age that we have added. And I want to have that at the front of the list. So I use a prepend. I could have used a happen, but then guess what? It would be it would have been put at the end. We have as well another way to actually modify documents using the JSON patch, so coming from standard RFC 6902. And it lets you actually define modifications to apply to a JSON data, but in plain JSON. So you can basically programmatically generate your JSON patch. And guess what? The JSON diff function actually does that. So for example, if you do the difference between these two small documents, well, you get the JSON patch to apply to the first one to get the second one. Other things that you can do, you can basically use PL/SQL. So you have a bunch of objects that you can use or types and method like if you want to actually work with a JSON field, so working on the key names aspect, you can use this way. And last but not least as well, you can benefit from the latest JavaScript engine. So you can create your stored procedure with a JavaScript language now. And you can load your libraries and, well, basically do whatever you want, like convert YAML to JSON or convert JSON to Tune. So the possibilities are, well, unlimited, I would say. So that's for modification. One of the things that I wanted just to show you, and I'm not saying you have to do it that way, but actually how you can do JSON schema bundling with SQL. So for those that don't know what is bundling, basically you can specify your JSON schema as very specific resources that way. So actually 3 JSON documents, but there are certain tools like OpenAPI that don't work that way. And they need to have the whole JSON document. So that one here, which refers the blue and the yellow subschema, if I may. And they want just to use that whole approach. So having a bundled JSON schema. This can be done in less than 30 codes of SQL, right? The example will be available at the slide as well, so I will not explain it, but you can definitely do it with recursive clause, with all of the features basically that we provide, even the one that actually apply JSON patch or generated. Now about JSON schema generation, there is interesting things like, what about all of the existing metadata? Can we bring much more value using some of them. So, for example, in 26AI, we have introduced database annotations that you can basically specify for table or column and a bunch of other objects. And here is an example where I'm actually adding the description annotation with a free text here, table containing employees. And I'm adding that annotation to the table empty. Secondly, well, when I generate a JSON schema from the table, I will get a JSON document. And guess what? Well, the annotations can be retrieved from the dictionary. So we provide a bunch of views where you can just retrieve annotation name and values. And so what I need next is just to leverage, for example, here a PL/SQL function where I'm just defining transformation of the resulting JSON schema here and adding the annotations to it where I'm adding some description or I can add much more things. And here is an example of what you get. So basically, the JSON schema generated without overlay, and when adding much more to it, well, we can see that the JSON schema being generated is richer and richer. And this brings a lot of interesting stuff for UI, for doc generation, or even for AI inference. And of course, we try to improve the database engine to make that entirely managed within the database for you. So it will come over versions, but for now, you know that already working with PL/SQL works very well. Let's continue on security and to just other examples. So we have seen that invisible columns work. So let's put that salary column visible again. And we have a feature called data redaction where you can create policies. So here, a very simple one, but that can actually control, given the context of the user connected to the database, and do some things with the data control without within a column, like here, setting it to null. So if you do that, actually, you can, whenever you do a select star from the traders, every salary will be like null value, where the stored or persisted values are still on disk. And if I use my PL/SQL function I showed you above, well, can generate that way. And I can, for example, introduce a new, my own keyword actually. So say X sensitive and say it's true. So my salary column is sensitive, right? So additional metadata again. What else? Well, you can create a lot of things like here, just basically these few rows helps me to create a REST data services where I can expose all of the JSON schema that I can have inside one table or inside the dictionary and expose them through a REST API. So whenever I query that one, that REST endpoint, I can guess at least a catalog basically of the different JSON schema available within my database. So you see the code that I had to write on the left, and it provides me already something very interesting that I can leverage on the middle tier or from my backend or even going through my front end if I want. Other things around RDS. So again, another topic in itself as well. So RDS provides us as well open API catalog for existing endpoints. And so this is very easy to get. And lately, what we have added is a support for GraphQL. So it comes with a GraphQL UI that you can see on the right, and of course, GraphQL endpoints. So you can as well query, well, a JSON schema registry, which could be a table for you, and get this catalog as well. So different ideas that, well, can help you for your work, for your job. And last but not least, we have introduced as well this new, so that's time to speak about GraphQL just a bit. The GraphQL operator, so if you like GraphQL, well, know that now you can definitely query your data using GraphQL syntax that way, right? So very convenient if you like it. And then using here, so you get JSON data, and then, well, you can just query it using the SQL notation that way. right? Casting into string here. What else did I try for with JSON schema? Well, I built a very small Apex application. So the Apex platform here too. So that's a low-code a platform to get access to applications that runs actually within the database, close to your data, and very, very easily. So here that one, 20 minutes to build it. And here, what I'm just showing you that I can pull remotely, for example, from source meta registry, some JSON schema. It will appear in that part, in that panel. Then I can specify my own data for validation, and I will get the report, right? So very easy and convenient way to use graphically the features available within the database that wrote an Apex app. And instead of getting outside for knowing, well, what they will do with my data, well, you control everything here. Interesting topic as well. So maybe you know about advanced queuing that has been improved for 26 AI, and now it's called transactional event queue. And well, basically that's a way to provide a queuing mechanism within the database with a transactional consistency. And that's where you can provide a JSON payload. Well, guess what? For this JSON payload, you can as well provide a JSON schema validation for your queue. We make as well the API, one of the API Kafka compatible, so then it gets something very interesting and very neat for you. And so basically how it works, well, you create a queue, you say the payload is JSON document, then you create a domain, you attach again a JSON schema to it, then, well, you alter the queue table. So you specify that the user data where JSON data will be stored, that it's actually a domain. So you add the constraint of the JSON schema to it. Then you start the queue, and then you can benefit from it. So if you enqueue an event that is valid or not for the JSON schema, it will work, or it will fail and raise an error. So I can show you how it works, but well, basically you will have all of the demo code available on a GitHub account. Last but not least, you know, all of the buzz around AI. Well, 26 AI version brings a lot of features for AI management. So basically here is an example of a similarity search and what it can bring for JSON schema. So that one is a way, and again, I will go through the example just for explaining a bit more, but basically you can load a model within the database. So it has to be in ONNX format for exchange, and you load it, then you create embeddings over your JSON schema, of course. You index it for, well, faster search, and then you can leverage some SQL function like a vector distance that will, well, do similarity search around your JSON schema. And I will show you some examples here. Like, imagine I have a table with the JSON schema I'm using in my enterprise, and then, well, I'm looking for some because I have some data to persist in a new table, and I don't want to, well, have a duplicate, for example. So now here is a way to actually introducing a function like a prompt for searching existing JSON schema based on a prompt. And here you see that because the model is multi-language, well, you can ask question in English, German, or French, and it works. So I will show you how it works actually with an example. And I think, yes, just before getting to the roadmap, so let's get to the example so that we can just learn together. So on my laptop, I've got this free container, so Oracle free, deployed, and I'm connected to it using the VS Code extension, right? So here, that's basically a SQL notebook where you can specify text, markdown, and pictures, and as well code. And basically, so I'm not sure that one is well, useful to show you because that's very much straightforward, right? Just remind about versioning that you have to use a virtual column to extract the value from your data. But the one that I wanted just to drill down a bit more is that one. So I was saying you have a table, you create your JSON schema table, you generate, you have the JSON column within which you will insert some JSON schemas, so the ones that you are using within the company. And then what I will do after inserting the documents, you can automatize that, for example, with a trigger or, for example, right? And I will just create the embeddings for these JSON schemas. So the way to do it, so let's just first create a table and insert the 3 schema. So here using the multi-values way to insert. I will load my ONNX model. So that's a way, basically very well documented. So you just create an external directory, you put your model, you provide some metadata, basically kind of always the same, and then you just load your model within the database. Once it's done, well, you can do stuff like creating vector embeddings, like vector embedding my model. I'm using the schema doc where the JSON schema is stored, so as data. And then I just update actually the 3 rows with the new embeddings. So now it's using the model and providing the vectors. Next, I'm creating vector indexes so that well, it will be faster for searching. And then I just need to create a query. I'm creating here a SQL macro, so that's kind of parameterized view, if you may. If I may, and then you can just specify a prompt. And basically, whenever I will query that function, well, it will run that query. And so you see here, it's looking for all the information, computing the distance, using the cosine distance function, providing the resulting JSON schema from my table, and then I'm ordering the results by the vector distance again, right? Fetching with approximation, and I just want to retrieve the very first one that I get, the closer actually from my prompt. And here is how it works, right? So for example, the first query, which schema contain a nested array of line items with discounts, and guess what? That's purchase order schema. Why? Because it's found out that there is probably somewhere line items here and other things that it found out within the vector. The second test is about the French prompt with find out for, or German one, sorry, for Mitarbeiter, and beta, I think that's the German word for worker, right?
Colleague, yes.
Or colleague.
Someone that works
No,
with you,
Mitarbeiter
yes.
is the more official one. I think you got it
Yeah.
spot on. Like
Yeah.
whatever AI tool help you. No.
Yeah, all right. And so it finds the employee, all right? It finds an employee and corresponding entries for that one, actually. And when you look for a document that looks like, qui ressemble à, that looks like this one, well, it finds out that this is the invoice schema that is the closer one, right? So that's basically just one small use case, but that can help you for your everyday work, right? Here, finding the best JSON schema to use or reuse versus creating a new one and, well, you know what, providing more and more JSON schema without, for example, which would necessarily need to be maintained over time. So I hope you find out interesting. So now let's drill down a bit into more on the roadmap side. I wanted to show you something very interesting that I found during the studying the supportability of JSON schema within database or Oracle database. So how do we compare to other databases? So basically here, PostgreSQL and MongoDB. And the results are quite neat, right? And very interesting because as you can see here, we are close to 100% versus MongoDB, which kind of stopped at draft 4, which is a very old one. And Postgres actually is using a Rust extension. So the synergy with existing database feature is not there, right? That's a program running outside Postgres. And so because, well, I spoke about the V1 version, so the kind of production ready, even if draft 2012 is production ready. But the V1 coming this year is already supported, and we comply close to 80%, so which is very appealing because, well, we can test already the V1 coming regarding JSON Schema. The other things that will be coming are things like richer JSON schema generation from the database dictionary. We have seen the things like vocabulary extensions for JSON schema very appealing for database, for example, but we may provide some new further specific features in the future. And there are other things that, well, we have integrated within 26 AI that may be think about with the JSON schema committee here. The SQL assertion. So that's very old feature from the SQL 92 standard, but that's basically a check constraints that you can put on multiple rows for a table, or even checking across tables, so multiple tables. And that one, well, definitely doesn't exist within the JSON schema standard. So that's probably something to look at for the future of the JSON schema, maybe V2, kind of. But anyway, so you see that, well, there is a lot of the both worlds, database and JSON schema, that combined together actually help more. So we are close to the end of this presentation. Wanted just to bring some final words, like, so database and JSON schema. Yes, the synergies are real. I think I showed you some, but given the fact that I provide you a GitHub repo, you can test it by yourself. But the thing is, I want you to get some homework, right? And so you can do much more with JSON schema, like versioning using the database dictionary with edition-based redefinition. I tested it works very interestingly. Property graph, spatial, GeoJSON, RDF, and melting all of these together can be very interesting. And again, 20 AI Enterprise Edition is available on Linux now. So thanks a lot.
Yeah, so
This
thanks
was
a lot,
great.
Mike.
Like,
Yeah, there was one question that we could not answer in the chat.
Yeah.
Like you talked about the low-code Apex platform that you developed for using remote JSON schemas.
Mm-hmm.
And you mentioned that it's on GitHub. The question was there, whether you could share where this application is.
Yeah, you just need to, well, there is a QR code. Basically, it will redirect you to one of my own repository on GitHub.
Okie dokie. So it is basically what we're just seeing.
Yeah, it's just here.
Okay. So this question is hereby officially answered.
Yeah, and please provide feedback, please.
Yeah. So someone is asking for the link of the barcode. I'm trying to see if I got it on my phone. Now let's see if we can also copy it into the chat.
Yeah, of course.
Let's see if I get that done. I think there were some people asked, like, how can I access this? Is that repo, does that contain everything you demoed here, or is there something that you've shown that is not on that GitHub?
No, I try to make the things rather straightforward. So explaining how you deploy the Docker image or ODS, all of that stuff. So the setup and then running the demos.
Perfect. Is everything you've shown available today on ADBS? Or I think some of the things you've shown, there was on like JSON diff and so on, I think we have not documented it all for the fullest extent.
Yeah.
We will definitely do that. But this works, right? Like if someone, like these examples all work today with a product, right?
Yeah, given that you have a 26 AI version of the ADBS, it should work. Yeah.
Mm-hmm.
So the link is now for everybody in the webinar chat to pick up.
Oh, yeah.
Perfect. It's twice there now. Herman.
Yeah, well,
Thanks.
you only
Oh, I only gave it to you
the
guys. Okay, sorry. Yeah,
hosts and
yeah.
panelists, right?
Oh,
My
yeah.
mistake then. Yes. Okay. My
Sorry.
mistake.
Yeah.
So
So we
thanks.
will cut that out that I had to correct Peter.
No, that's fine. You correct me. That's always good. I like that.
All right. Thanks.
Cool.
Yeah, it's a chance. If anyone has some question, I see people thanking.
Yeah.
No
So
questions.
thanks a lot
Oh, there's
for
like
staying.
Q&A. Hold on, wait. There is something in the Q&A.
Okay.
Can I describe a whole schema like I describe a table with DBMS JSON describe table? DBMS JSON schema describe. Oh,
Not
it's basically you want to describe a whole database schema. So you want to get an array with. Actually, that's an interesting idea, but it would be large, I guess, right? So we could iterate over all the tables, over all the types, over all the
Yeah.
views. We could have like I don't know, like can the person, it's anonymous. Can you maybe have another question or a chat, like what problem you would try to solve with this? I mean, we can code all day long, but I'm not sure if we just dump everything, if that would help it. So then there is another question. How much of the feature examples you have shown are available for the on-premise version? I think if you have 26 AI, you get all of this, right? There's
Yeah.
no real difference between ADBS and
I didn't explain how to install Apex basically,
Yeah.
but because I remember I made the example on ADBS, but you've got the Apex application, so maybe the hardest one is probably to install Apex. But once you get there, well, I'm using the free edition, right? So the ones that you install on premises, so you get everything with on premises.
Right. There was a person asking to share the Apex app. Like, is the Apex app in your GitHub repo?
That's in the GitHub repo.
Oh, that's in there. Good. Yeah.
Yeah.
So if we talk about on-prem, it would have to be 26. So we do not backport anything about JSON schema really to 19C because there is no JSON data type, like column data type in 19C. We do support JSON data in 19C, all the operators, but JSON schema is not supported on 19C. So we got the follow-up. Well, I was thinking of describing the whole schema to check for changes using some versioning compare.
Actually, I have some. I can bring maybe some information here because when I showed you the actually the we call it the migrator from JSON to JSON Duality views. Well, we can actually have the JSON schema being generated, and when it covers several tables, well, we have actually, as you mentioned, Beta, an array of the tables and corresponding JSON schema. So I'm wondering if there is something to look at with that.
Why don't we do this? Like, does your first slide show your email or contact info? Like, why don't we ask the guest to reach out to you or to any of us?
Or maybe just create an issue on the GitHub repo.
Yeah. So I can put my email in the chat. Just like I would appreciate if you would reach out to us, that we understand the use case. I think we could be doing a lot of things, but JSON schema, for example, has some limitations regarding obviously some constraints. Like we translate constraints as much as possible to JSON schema. If we cannot do that, I think we believe we dump the JSON string. But if you, for example, have changes in PL SQL trigger code, you would not see those in a JSON schema. So I think we can give you a lot about the schema, but we may not be able to map 100%. Yeah, we see a lot of development going into JSON features. Do we expect in future you make JSON mainstream and slowly move away? No, we will definitely not move away from relational things. The main story is we want to be your data platform for all your data needs. And some of your data needs may be JSON, some of your data needs are graph. A lot of it will remain relational. Vector is coming. So this is not a shift away from something. This is really more building a data platform broader, where you can run different data models with the same security, with the same transaction model. You can have workloads that span different data models that say join, vector, and relational and JSON. So
I
it is definitely the case that we are investing heavily into JSON, but not at the expense of any other data models. It's really a platform play.
Yes, I think just to add to what Peter just said, our clear strategy for the Oracle data platform is to address the market demands. And we added JSON, just like we just more recently added vector, or just like we added XML, probably, what is it, 20 years
20
ago?
years ago.
Something like that, were all market demand driven requirements coming from you, from our customers. And this is what we're gonna continue to do. It's not a plugin or an extension like you see it with other databases where you just have someone, to build something that is forked on. This is all kernelized and integrated into the database, right? So if we're doing this kind of converged database approach to build the data platform, it is kernelized. Just like we built the JSON collection tables for JSON, just like we integrated all the JSON schema capabilities that Loic has shown today, walked through. This is all standard default part of the Oracle data platform. So it's not about, I think on a high level, it's not about replacing X with Y. So we haven't replaced the relational schema with XML 20 years ago. We will not replace it with JSON, and we will not replace it with the next trend that we probably don't even know yet exists. And ultimately, at the end of the day, right, relational is probably still running the majority of the enterprise world and has the most comprehensive integration into the surrounding ecosystem of applications. So it's all about synergy and coexistence rather than replacement.
And if I can add, if you look at the SQL standard itself, it's evolving in the same way as adding more over time versus just selecting the thing that is trendy, right?
Okay, then I think, let's see, Q&A. We answered all the questions live. This is good. And with this, I thank everyone for attending this session. I do believe we have another one coming up in 4 weeks or so, and that will
Yep,
be
that's the next
another
slide, I think.
Yeah, I think so.
another deep dive about some of the internals OSINT. So we had a person recently, like a pretty technical person joining from the company called MongoDB, very familiar with their technology, and he decided to join Oracle and looked into our story, into our like binary representation performance, and found some very interesting aspects where we do things differently and apparently also very good. And he will give a presentation together with a lead engineer behind this data model. So this will be, I also think, a very, very interesting session.